Hello everyone, I am Ajay Kumar, Assistant Professor Mechanical Department from Rohini College of Engineering and Technology. In this video, I am going to discuss about the subject finite element analysis. The subject code is ME8692. So I am going to discuss a small topic in Unit 1 of finite element analysis, and the syllabus coverage of Unit 1 is historical background of finite element analysis, mathematical modeling of field problems in engineering, governing equations, discrete and continuous models, boundary, initial and eigenvalue problems, weighted residual methods, variational formulation of boundary value problems, Ritz technique, basic concepts of the finite element method. So next we want to see the course outcome of Unit 1. After successful completion of the program of Unit 1, the students can be able to apply the basics of finite element equations. And the highest cognitive level given for this Unit 1 is K3, that is applying level. So in this video, we are going to discuss about the introduction to finite element analysis and the basic steps of finite element analysis. So before that, we want to know the methods of engineering analysis. There is three methods of engineering analysis, that are experimental methods, analytical methods, numerical methods or approximate methods. So first we want to see the experimental method. In this method, prototypes can be used. If we want to change the dimensions of the prototype, we have to disassemble the entire prototype and reassemble it, and then testing should be carried out. It needs manpower and material, so it is time consuming and costly process. Next one, analytical method. In this method, problems are expressed by mathematical differential equations. It gives quick and closed form solutions. It is used only for simple geometries and idealized support and loading conditions. And the next one is numerical methods or approximate methods. Analytical solutions can be obtained but only for certain simplified situations. For problems involving complex material properties and boundary conditions, the engineer prefers numerical methods that gives approximate but acceptable solutions. The following three methods are coming under numerical solutions, that is functional approximation, finite difference method and finite element method. So finite element method is a numerical method for solving problems of engineering and mathematical physics. In this method, a body or structure in which the analysis to be carried out is subdivided into smaller elements of finite dimensions, that is called as finite elements. Then the body is considered as an assemblage of these elements connected at a finite number of joints called nodes or nodal points. The properties of each type of finite element is obtained and assembled together and solved as whole to get the solution. So next we want to see the general steps of the finite element analysis. There are 10 steps followed in the general steps of the finite element analysis, that is discretization, numbering of nodes and elements. The first two steps are coming under pre-processing, and selection of displacement function, define the material behavior, derivation of element stiffness matrix and equations, assemble the element equations, applying the boundary conditions, selection of unknown displacements, computation of the element stresses and strains are coming under analysis. And the 10th step, interpret the results, is coming under post-processing. So the first step is discretization of structure. The art of subdividing a structure into a convenient number of smaller elements is known as discretization. Actually, the smaller elements are classified as one-dimensional elements, two-dimensional elements, three-dimensional elements and axisymmetric elements. So one-dimensional elements are bar and beam elements are considered as one-dimensional elements. Two-dimensional elements, triangular and rectangular elements are considered as two-dimensional elements, and three-dimensional elements, the tetrahedral element and hexahedral elements are considered as three-dimensional elements. An axisymmetric element means the axisymmetric element is developed by rotating a triangle or quadrilateral about a fixed axis located in the plane of the element through 360 degree. The step 2 is numbering of nodes and elements. The nodes and elements should be numbered after discretization process. The numbering process is most important since it decides the size of the stiffness matrix and it leads to the reduction of memory requirement. While numbering the nodes, the following condition should be satisfied, that is, maximum node number minus minimum node number is equal to minimum. So there is two type of numbering process, that is longer side numbering process and shorter side numbering process. And this figure you are seeing in this slide is the example for longer side numbering process. So we are considering the element 3. So when considering the element 3, the maximum node number is 10 and the minimum node number is 3. So the difference is equal to 7. So the next is shorter side numbering process. Considering the same element 3, the maximum node number here is 14 and the minimum node number is 9 and the difference is 5. So from considering the longer side numbering process and shorter side numbering process, the shorter side numbering process is followed in finite element analysis because it reduces the memory requirements. And the step 3 is selection of displacement function or interpolation function. It involves choosing a displacement function within each element. Polynomial of linear, quadratic and cubic form are frequently used as displacement function because they are simple to work within finite element formulation. The polynomial type of interpolation functions are mostly used because of the reason it is easy to formulate and computerize the finite element equations. It is easy to perform differentiation and integration. The accuracy of the results also improved by increasing the order of the polynomial. So the example for linear, quadratic and cubic is linear. For example for linear is ax plus b is equal to 0. For quadratic, ax square plus bx plus c is equal to 0. And for cubic, ax cube plus bx square plus cx plus d is equal to 0. And step 4 is define the material behavior of by using strain displacement and stress strain relationship matrix. Strain displacement and stress strain relationship are necessary for deriving the equations for each finite element. In case of one-dimensional deformation, the strain displacement relationship is given as E is equal to du by dx, and u is the displacement field variable along x direction, and small e is equal to strain. The stress strain relationship is given by sigma is equal to capital E into small e, that is sigma is equal to stress in x direction, small e is strain, and the capital E is Young's modulus or modulus of elasticity. And the step 5 is derivation of element stiffness matrix and equation. So this is the finite element equation is in matrix form, that is fx1, fy1, fx2, fy2, fx3 and fy3, that is k11, k12, k13, k14, k15, k16. Same will be followed as in the below rows, that is k21 to 26, k31 to 36, k41 to 46, k51 to 56 and k61 to 66, and then it is displacement function ux1, uy1, ux2, uy2, ux3 and uy3. The compact matrix form is Fe is equal to Ke is into Ue, that power E means element. And the step 6 is assemble the element equations. The individual element equations is obtained in step 5 or added together by using a method of superposition. The final assembled equation, which is in the form of F is equal to K into U. F is equal to global force vector and the K is stiffness matrix, that is global stiffness matrix, and U is the global displacement vector. And the step 7 is applying boundary conditions. Certain boundary conditions are applied so that the structure remains in place instead of moving as a rigid body. The final assembled equation should be modified to account for the boundary conditions of the problem. If a board problem is given, we should see the fixed node. If it is a fixed nodes, we want to put the displacement as 0 for the fixed nodes. This is the example for applying boundary conditions. If a force is acting as a node 2, so we want to put as F2 is equal to that the given force, but for F1 and F3, if there is a 3 nodes in a problem in a bar element, if in the 2, if the force is acting in the node 2, we want to consider that node only for force acting. The remaining nodes, the force acting is 0. And the step 8 is solution for the unknown displacement. A set of simultaneous algebraic equations formed in step 6 can be written in expanded matrix form as F1, F2, F3, F4 to number of F, and same like K11, K12, K32 number of K1 and 2, Kn1, Kn2, Kn3 to Knn. So next it is a displacement equation U1, U2, U3, U4 to Un. This equation can be solved when unknown displacements are calculated by using Gaussian elimination method or Gauss-Seidel method. Step 9 is computation of the element strains and stresses. In structural stress analysis problems, stress and strain are important factors. From the solution of displacement vector U, stress and strain value can be calculated. In case of one-dimensional deformation, the strain displacement relationship is given by E is equal to du by dx. That is, du means u2 minus u1 and dx means x2 minus x1, where this u1 and u2 are the displacement at node 1 and node 2, and the x2 minus x1 is the actual length of the element. From that we can find the strain value by knowing the strain. Stress value can be calculated by using the relation stress is equal to sigma is equal to capital E into E, where capital E is young's modulus and small e is strain. And the step 10, this is the last step, that is interpret the results. Analysis and evaluation of the solution results is referred to as post-processing. Post-processor computer programs help the user to interpret the results by displaying them in graphical form. Hope you all have an idea about finite element analysis, the basic steps of finite element analysis by watching this video. So the main reference of this presentation is from the textbook of Dr. Sendil and Mr. P. Panidas, the finite element analysis by Lakshmi Publications. Thanks for watching. If you have any doubt, you can able to mail to me ajikumar.aero, that is aero@gmail.com, and my mobile number is 8754330058. For any queries, you can able to contact me in this WhatsApp number, and also my email ID ajikumar.aero@gmail.com. Once again, thanks for watching this video. Thank you so much.